All right, so this lesson is about some other kinds of factoring. We talked about trinomial factoring in class, which is the hardest. So now some of the other kinds, GCF and dots. We'll do GCF first. Now, a GCF is a greatest common factor. Now, what a factor is, like if we factor 10, it's 2 times 5. Factors are numbers you multiply to get the original, which also means you can divide something by one of its factors and there's no remainder. Now, you may have in the past, maybe in like 6th grade, maybe 7th, probably not, maybe 6th though, seen something like number 1. It's kind of like backwards distribution. Your answer to this is going to look like a distribution question, and I'll explain why. But we have 18b plus 45. Now, there's no b in the second term, so there's no common variable in them. So we don't have to worry about a variable in our GCF on number 1. And I'll explain what I'm talking about when we hit the second one. We just got to look at the numbers. So you ask yourself, hey, well, what's the biggest number I can divide both 18 and 45 by? And if you're good with your times tables, you know that's 9. So the way this works, you put a 9 out front, you put your GCF out front. Now there's a binomial in the original question, so I'm going to leave room inside parentheses to write a binomial. Now, really what you're doing here, like I said, a factor is something you can divide by without getting a remainder. So what you're doing here, you're kind of like dividing. You don't have to write that down every time. If it helps, write it down. The way I usually think about it is, hey, what do I multiply 9 by to get 18? And that's what division means, but I multiply 9 by 2 to get 18. 18 divided by 9 is 2. We didn't do anything with b. Copy the plus down. 45 divided by 9 is 5. And that is your answer. Like I said, the answer to this looks like a distribution question. The reason is when you factor something, you break it up into a product, into multiplication. If you're asked to distribute, you're multiplying. So they're opposites. Just like the easy 10 is 2 times 5 up there. If you factor 10, you write 2 times 5 down. If you multiply 2 times 5, you write 10 down. And you could do the distribution as a check, but on one like 1, you don't have to. Now, on 2. Well, there's no number in front of that x to the 4th. So there isn't like a numerical GCF like there was on the first one, but we have x's in all the terms. There are factors of x common to both. Now, you don't have to do this every time. This is just an explanation. If you got really large exponents, you wouldn't have room to do this. So I'm just going to explain by expanding these out. X to the 4th is x times x times x times x. X squared is x times x. GCF stands for greatest common factor. So we need the greatest number of x factors that are in both terms. Sure, the first one has 4 factors of x. Remember, factors are multiplied. X times x times x times x. There are 4 factors of x there. The second one only has 2 factors of x. If I can only have the number common to all of them, the number of factors, the greatest number of factors of x common to both terms is only 2. The second term, the 3x squared, only has 2 factors of x. So that's the greatest number common to all of them. The first one has 4, but the second one doesn't. Now, the rule is, if there is a variable in all of the terms, the same variable, of course, like I couldn't do, if that was y to the 4th plus 3x squared, I couldn't do anything. But if there is a variable in all your terms, and it has to be in all of them, or else it's not common to all of them. Go with the lowest exponent. So, in number 2, the lowest exponent of x is x squared. And then you think about it like this. I have x to the 4th in the original question. I am factoring out. I'm basically dividing out 2 powers. If I suddenly take these 2 powers and those 2 powers out of both, if you have 4 in the first, you take 2 out, you got 2 left. And then we have x squared in the second, we take 2 out, 2 powers of x out, no more x left. It's like I'm reaching into both terms and grabbing out all the x's I can take out of all of them. Since the second one only has 2, I can only take 2 out of all. Number 3, well, there isn't an x in both of them, so there's no x part to a GCF. What can I divide both 8 and 16 by? Well, I can divide them both by 8. What do I multiply 8 by to get 8? 1. What do I multiply 8 by to get 16? 2. Didn't touch the x. And again, like if it's better for you to think division, it's just 8 divided by 8 is 1. 16 divided by 8 is 2. And there isn't an x in everything there, so you just bring that down with you. Now 4, hey, on 4 we got both. We have a number and we have a variable. What can I divide both 15 and 25 by? I can divide them both by 5. Now there is a b in all of my terms there. Go with the lowest power. B cubed. 15 divided by 5, or what do you multiply 5 by to get 15? 3. I started out with 7 powers of b. I reached in and I took out 3. B to the 4th left. 5 times 5 is 25. I factored out b cubed. No more b's left. Done. 16r squared minus 6r plus 8. Well, you look through there, 16's got an r, 6 has got an r. Oh, 8 doesn't. So, these last two questions of this GCF factoring, they have 3 terms. We could do this for 4 terms or 20 terms or 100 terms. Well, I wouldn't want to, but we could. There would have to be an R in every single one, but there isn't. So R is not part of my GCF. Since there's not a variable in every term there's no variable in my GCF. What can you divide 16, 6, and 8 by? You can divide those all by 2. 16 divided by 2 is 8, or like I said, hey, what do you multiply 2 by to get 16? 8. Didn't touch the R's, bring it down. I multiply 2 by 3 to get 6. Didn't touch that R, bring it down. 8 divided by 2 is 4. Now 6, a 2, a 5, and a 4 for my coefficients there, the big numbers. I can't divide those by the same number. You got a 2 and a 4 and a 5. 5 is prime. Can't do anything with the numbers, but hey, this time, there is an n in every term. So go with the lowest exponent. 3. N cubed is my GCF. Again, I didn't touch the numbers, so I'm just gonna drop that -2 down. My leading term in the question had 7 powers of n. I took 3 out. You got 4 left. Didn't touch the numbers, dropping that 5 down. N to the 4th, I got 4 powers of n. I reached in and I took 3 out. N to the 1st, or just n. And the last term, the 4n cubed, I am factoring out all 3 powers. No more n. Now, like I said, if you went through and you distributed that, you would end up with the original. Because I don't know if you remember, but when you multiply x's or n's or g's or whatever letter, you add their exponents. So if I were to go through, and this is not part of the question, this would be like a check. If I were to go through and do all this distribution, 3 plus 4, 7. 3 plus 1, 4. And then just n cubed times 4, 4n cubed. Sometimes what happens is people are trained so much to distribute, they'll factor something great, then they'll distribute it because they're trained to distribute, and then in the Regents, they write down the original question as the answer. Don't do this, the distribution. I'm just trying to explain how this works. What's in purple there, that's the answer. Sorry about that. Now, excuse me, sorry about that. The next type of factoring, dots. The difference of 2 squares. Difference in math means minus. It has to be a minus in between the 2 terms. Can only do this when there's a minus sign and there's 2 terms, and it says 2 squares. These are the perfect squares that we talked about. 1, 4, 9, 16, 25, 36. When we did that simplest radical form, we used that list of numbers. Now, the way this works, this one's kind of similar to that trinomial. You do your double parentheses. One always gets a plus, one always gets a minus. And you could put the minus first, then the plus second. Doesn't matter as long as you got one of each. Then what you do, you take the square root of the first term and put it first. Well, square root of x squared, squaring and square rooting cancel each other out, so that's x. Square root of 1 is 1. That's it. That's the answer. Dots is really, really easy after people like get it. If they remember it, it's really easy. The reason that this works, and what I'm about to do is not the answer. This would be like a check. And I'm just explaining why it works. If we were to do that double distribution, x times x, do not like this board. X times x is x squared. The reason that you get a plus and a minus is watch what happens. These are the same numbers. And you have the same variable first in each parenthesis. So since they're opposite signs and the numbers and the x's are the same, you're always going to end up with a negative and a positive of the same term. They will cancel. Since you have a plus and a minus, a positive times a negative is minus. 1 times 1 is 1. That's why the question has to have a minus sign in it, so that those middle two terms will cancel out. Now again, what's in red there is a check. You see, it's the original question. Do not write that down as an answer. Do not write that down as an answer. That's the answer right there. And you don't have to check it, really. I mean, if you know your perfect squares, this should be really easy. Like 8. Now, I mean, 8 has a little extra thought there because you got that 16, but you just say, hey, what's the square of 16? 4. With your x, 4x goes first in both. 1 gets a plus, 1 gets a minus. Square root of 9 is 3. Done. Number 9. Square root of 16, 4 with the n. 1 gets a plus with 5, the other gets a minus. Now that's the reason that they have to be perfect squares as well. Because when you put that first number, like the 4 there, you're going to end up doing 4 times 4. And you get 16, a perfect square. Number 10, same idea. And this one, I'll do the minus first. Doesn't matter, as long as you have one of each. Square root of 4 is 2. Square root of 25 again is 5. And this works the same way. If the variable is second, doesn't matter, just put it second. Square root of 16 is 4. 1 gets a plus, 1 gets a minus. The square root of the second term, 5 with the b. There you go. Number 12. Square root of 49 is 7. Put that first. 1 gets a plus, 1 gets a minus. Square root of 100, 10 with your x. That goes second in both. Done. Really, dots is the easiest kind of factor. If you recognize your perfect squares, it's the easiest. Whereas with like trinomial and even GCF, there's more than just perfect squares, so you got to be good at your times tables. But that is the explanation for those two kinds of factoring. Hope that made sense.